We will talk about Metropolis on Jetson and VST in particular. VST stands for Video Storage Toolkit. We will briefly touch upon what VST is, and then we will take you from bare metal to live video streaming as fast as possible. VST brings a lot of new functionality. It collects video, audio, metadata. It does it from multiple sources, and it stores all that data synchronously and then allows to stream it synchronously. We also provide a module called NVStreamer that allows stream simulation, and of course the VST integrates very easily with all other NVIDIA toolkits, APIs, and we will provide examples how it does it with third-party APIs as well. Some major features: on with S input, RTSP input, WebRTC input and output. It stores all the above formats. It has accelerated H.264 and H.265 encoding and decoding, accelerated composition of data and video, external trigger-based recording, schedules, events, alerts, diagnostics, and this is what VST looks like on the inside. At the back end, we see the WebRTC streaming engine. There's also RTSP pass-through that allows to stream video directly from the camera to the output. Once the storage is done, videos can be then picked up and composited with metadata, for example, encoded again and sent through WebRTC. NVStreamer is a very useful test tool. It allows to convert any disk file into one of the formats listed here. Very useful when you try to do some repetitive testing. VST is a small part of a much larger platform, Metropolis on Jetson. You will hear a lot more about this platform in the very near future. Let's go back to VST, and I'll present now a sample installation procedure. DevKit and Ubuntu host need to be connected directly to a router, so they need to be on the same subnet. You could also use a PoE switch to connect your cameras, and if you'd like to be using a sample Android application code, you will need the Android device to run it. This is a diagram that shows installation angles. Roll shouldn't be bigger than 30 degrees, and angle to vertical should be between 30 and 60 degrees. First, we will need to install Jetpack 6.0 or newer. We will use SDK Manager to do so. SDK Manager requires x86-based host running Ubuntu operating system. We'll then connect host to target device using USB data cable. Please make sure that your host device runs Ubuntu 20.04 or 22.04, as those are the only two ones supporting Jetpack 6.0. We will also be able to reuse Ubuntu host as NVStreamer machine later on. Since the target device or AGX dev kit will have to be flashed, we'll have to put it first in forced recovery mode. This page explains how to do that. First, you press and hold the middle button. Then, while holding it, you press and release the button closest to the power supply. Then, release the middle button. Finally, use the USB data cable to connect target machine to the host machine. With host and target machines connected, you can now launch the SDK Manager. When you launch it, you should see a menu not unlike this one. If you do not see any pop-up menu, it is possible that the AGX dev kit did not go into recovery mode. Let's try and force the dev kit into recovery mode again. Make sure that the dev kit is powered up. Then While powered up, press and hold the middle button. While holding it, press and release the button closest to power supply, and then release the middle button. If you still experience problems, here's a top tip on how to verify if your device went in recovery mode. Run LSUSB and see if you can see 7023 next to NVIDIA Corp line. If it's there, it is in recovery mode. If it's not there, there's some problem still. If that is the case, please try a different USB port on your host machine or try a different host machine. If different host machine is not an option for you, please contact us via forums. If you do see the list, please select AGX Orin DevKit 64 or AGX Orin DevKit 32. Please do not select industrial versions of the DevKit. Once you select the appropriate DevKit, click Continue and proceed with flashing. If the flashing procedure is unsuccessful, here's another top tip. Reconfigure the USB core on your host machine like so. Force the DevKit into recovery mode and retry the flash. Once the flash is completed, please log in to target device. Use this command to check if Docker is installed. If it's not, please follow the instructions on this website to install Docker on your target machine. Run sudo to download and install the Docker packages, and once you do, run this command again to verify that Docker is correctly installed. From the target machine, log in to your NGC account. Go to Settings and obtain API key. Copy the API key and then use this command followed by the API key pasted here to log in to NGC. Now that we are logged into NGC, we'll use command line to pull the container. Before we do, let's examine the content of VST configuration file. We will use Visual Studio Code running on the host to edit the config file on the target. I do not suggest it, but you can pull the Docker without config file like so. Save the template config file to this directory. Open Visual Studio Code to edit the config file. I would suggest that you at least modify the target storage. Storage on eMMC is not suggested. Once you modify the file, pull the Docker using this command. Observe where the VST config is mapped and pull the Docker. In the command line of the target device, observe that the Docker is running. Use the IP address of your target device and HTTP port in VST configuration file. Use that information to open the UX of VST. In this particular UX, you can see that there are 8 cameras. They are currently locked. And just as a reminder, the diagram of connections. Let's go back to VST UX and see how to effectively use it. The cameras are still locked. We will need to input passwords. The cameras are not recording. The camera names have been set per the VST configuration file. If for some reason you do not see any cameras, force the scan using this UI. Each camera comes with its own username and password. Input them in this UI. The UI will inform you if you used correct username and password combination. If you do not know the default username and passwords for your IP camera, please consult that camera's user manual. Select each camera from the list and use this UI to input username and password for each camera. Now that we have correct username and password for all cameras, you can see checkbox instead of padlocks. If you no longer need a camera, you can remove it using this UI. Let's look at camera configuration page. In this page, you can access most of the parameters available through OnWithS. Please note that OSD settings are not available in this page. For example, the clock needs to be set on camera web server. If one of your cameras is broken or damaged, you can maintain the continuity of recording by replacing it with a different camera. In this UI, you can set recording to on or off on per camera basis. You can also change its schedule. The fact that camera is recording is reflected in a list of cameras. In this UI, you can see that 7.2 gigs of disk space have been already taken, all cameras have been authorized, and all cameras are recording. In this UI, you can see RTSP stream for each camera and amount of disk space used by each camera. Each camera can be given user-friendly name. Please note, these names do not translate to OSD camera settings. Let's see the live stream from camera. Use this UI to select camera you would like to see. You can select more than one camera at a time. You can select up to 8 cameras on Orin NX and up to 16 cameras on Orin AGX. A red dot in the top right corner indicates recording. The OSD settings are camera settings. You have to go to camera website to set them. Select Recorded Stream Stop to view recorded videos. Here we will use the OSD settings to verify that camera is recording. Look at the OSD settings and verify the same time is displayed in the timeline below. As you scrub through the timeline, observe that the OSD settings are modified accordingly. You can also return back to live streaming by clicking the Live button in the bottom right corner. An alternative way to display multiple videos is what we call a video wall. Select videos that you would like to display in it. You can select up to 9. Once you select the videos that you're interested in, click Start. Let me show you a couple of basic code samples with accompanying UI. We will start with adding the stream. In order to add the stream, go to the camera management and scroll down to add device manually section. It could be stream, could be device or camera. You can type in the RTSP here, and you have to give it a name so that you can refer to it in the code, and then click submit. Wait for a second, you'll see a green field, and you're done. Here's what happens behind the scenes. We first prepare JSON data. We give a name that I just input in the UI. And depending on whether you want to address the camera by IP or access its RTSP, you choose one of those options here. And then with that JSON data all pre-filled, you execute the API that adds the sensor to the system. Each camera that has been added can also be removed. You can do it in UI by clicking Camera Management and then going to Remove Camera option. You select the camera from a list of cameras that had been added, click Remove, and that, again, green field confirms the success there. All it takes to remove a sensor in the code is to execute API sensor with sensor ID obtained in the previous function. Now for some live streaming API code. As we've seen before, in order to start live stream, you click live stream, select the camera or stream that you added, Wait a second, the stream should start. Let's see how that works in a code behind the scenes. You select an API called live stream start with a JSON containing tags like client address, peer ID, options, stream ID, and session description. You also need to execute the appropriate WebRTC API. For recorded version of the API, let's look at the UI first. You click on recorded streams. You select camera that has been recording for a while. It should start streaming in a second. There we go. Let's see how that works in the code. You select API called replay stream start with JSON fields similar to seen before, client IP address, peer ID, options. In addition, you have to select start time and the end time. And as before, you have to execute the appropriate WebRTC APIs with them. For the last example, let's see how to start or stop the recording. In the UI, you select record settings and select the camera that has been previously discovered. Click on off or on, depending what you want to do there. We'll start with on. You'll see success here. In JavaScript code, you select one of two APIs. To start, you select record start, and to stop, you select record stop. And as in the previous API examples, you have to obviously use the ID of a stream that has been previously discovered. Let's look at the NVStreamer. NVStreamer can be installed on Ubuntu host previously used for flashing of the target device. Since the NVStreamer is also containerized, you need to make sure that Docker is installed on the host machine. Repeat the procedure to obtain a key and log in to NGC using this command, followed by the API key for NGC. In this UI, I use terminals to access both target and host machines. Before we pull the container for NVStreamer, we need to create a directory that will be used by NVStreamer to store all the files to be streamed. In this example, this directory name is simply NVStreamer. Use that directory name as one of the parameters in Docker command displayed in this video. Observe mapping between the host and the container. Execute this command to pull and run the container. Once the container is running, it will enter main loop, and you will be able to see the IP address of the host device. Use that IP address to open NVStreamer's web UI. We will now create an RTSP stream using a static video file. Let's open web UI of VST on the target machine and web UI of NVStreamer on the host machine. On NVStreamer UX, locate File Upload tab. Select a file from the disk and drag it over to the icon. The RTSP stream will keep the name of a static video file, test recording in this case, and you can see it streaming in this tab. In the next section, we will find out how to use that RTSP stream in VST. Localize NVStreamer dashboard, find test recording, copy the RTSP stream stroke. Now open the VST UI. Go to Camera Management tab. Scroll down. Click RTSP. Paste the string. Make sure that there are no spaces in front of the string. Assign a friendly name to the stream so that you can identify it later. After a short while, you will see a green field identifying success. From this moment on, the RTSP stream will be treated just like any other camera you used in the past. Select Live Stream tab, friendly name, and observe streaming. This feature allows you to perform repetitive testing on files that you might have captured in the past. You can use VST Web UI to observe the quality of the video stream. Select the Debug tab. Select the video stream. Wait for a couple of seconds to see WebRTC parameters, frame rate, bitrate, and other parameters pertinent to the WebRTC stream. At the bottom, you will see network bandwidth. Repeat the same procedure for any video stream you are interested in. You will see different set of parameters depending on whether this is a file or a live camera. Here you can see that the bitrate fluctuates dramatically, which indicates setting on a live camera is not constant bitrate. And this concludes our webinar. Please examine the documentation available in NGC. You will be able to see the detailed set of features available with this release. You can also find a list of OnVIF-S cameras we have pre-tested. In general, any OnVIF-S camera should work with VST. As we discussed, it is quite useful to modify the VST configuration file. Find the VST section of NGC documentation to find the description on each key of the VST configuration file. In particular, please pay attention to storage configuration. NVStreamer configuration file shares similar set of keys. Now that you have successfully configured VST and NVStreamer, you can start configuring your setup. You can examine every REST API available for your use in this documentation. You will also find a section containing lists of all the known issues. This concludes our webinar. Please remember, the Metropolis on Jetson will only be available on Orin platforms and Jetpack 6 or newer. Good luck and enjoy VST and Metropolis on Jetson.